I think we're recording. It looks like it. All right. So if you're not familiar with the Elm Package repo, you should be, because it's extremely useful, and you're not going to get anywhere without using it. So if you want to follow along, you can go to package.elmlang.org. I actually also use a Mac app called Dash to view docs, and this actually really speeds up my development process because I've got Elm inside of Dash, and inside of here, the whole Elm Package repo has documentation has been pulled down. So let's say I wanted to use like Elm Combine. I could just type combine, and there are my docs right there. It makes it a lot faster than trying to go and search the web. So yeah, this is offline. So if you're interested in this, I actually had to build the doc set because it's like 2 months old, so I had to just pull down the source and build it. But I can just give it to you. It's a zip file. So talk to me after if you are interested in that. No, that's an app called Dash. It's like $20, but it's great. It's good for documentation. All right, so here we are on the Elmlang package Elmlang repo. That doesn't make any sense. Here we are on the Elm Package repo site, and let's go over quickly the structure of this site. So this search bar right here, as far as I understand it, will search through third-party libraries through their name and description. So let's say we're going to look for the library Elm Combine here. Oops. Combine. It'll filter it live, and we get to go look at this third-party library. All of the packages in the Elm Package repo are namespaced by a user's GitHub username and then the package name. They're all that way. And the purpose of that is to be able to allow everyone to have their own versions, basically, of a popular app, and anyone to be able to use those without having to be like, oh, do you own the repo? I don't know. Do you own it? You know, just fork it and push up your own version if you're unhappy with how it works, and they won't listen to your requests. There's probably actually a more friendly reason than that, but that seems to be effectively how it works out. Okay, over here on the side, you've got popular packages, but extremely important right here is core under general. If you're just getting started, you're probably going to spend a lot of time in this core package. And I think you can find that just by searching core here. Yep, Elmlang core right there. I wish that the core docs for these modules were integrated with all the rest of the search, because it's kind of confusing to have both of these search boxes. But here is where you can find things like map, you know, all of your basic functions that are built in with the basic types that ship with Elm, right? So like if you want to find how to use a list, oh, list right here. And inside of list, you've got descriptions for how these things work. Let's say you want to go into basics, you can get descriptions and type signatures for things as simple as equality. Cool? All of these modules that are on the side are available for use just with an Elm installation. You don't have to install any third-party packages. Everything in core, correct. So you can just straight up import any of these things and they work. Whereas anything else out here, you're going to have to use your Elm package JSON and say Elm package install, like exploding socks Elm type extractor. Plug for my library. Don't go look at it because it's not actually useful yet. Someday it will be, maybe. Okay, let's jump into core and let's go look at some type signatures. Let's explain what they mean, because there's some weirdish looking stuff. Okay. Who here has heard of Hindley Milner before? Have you heard that name, those names? Hindley Milner? Joe has. Hindley Milner type notation is what we're looking at right here. See this type with the arrow after the colon? This is a notation for explaining data types that was invented by these people, I'm assuming, I don't know, 70s probably? I don't know. Whenever Haskell started to be written, yeah. But it turns out to be a very concise and extremely descriptive way to express types. So let's go over what the parts of this notation are and what they mean. So here we have, on the left side of the colon, the name of the thing we're defining. This could be a value, could be like, basically this is like var blah equals. This is the identifier that goes after the var in JavaScript. But I guess it's a little different in Elm. but not different enough to really differentiate here. So this is basically the variable name, right? Or the function name. Then on the right side, separated by these little arrows, are the function arguments and return value. So here we have isEmpty is a function that takes one argument and returns a bool. And the argument that it gets is a list of lowercase a. Does that make any sense? All right. So uppercase letters dictate a concrete type. Right here. List with an uppercase L dictates a concrete type of list. That's defined somewhere right here. It has types associated with it. Like it's a real thing that's programmed out. Lowercase letters or lowercase words are placeholders for other things that can be there. And they indicate a polymorphic function. So right here, list is a polymorphic constructor. You don't have to like write a new data type in order to have a list of booleans, and then write another one that's a list of strings, and then write another one that's a list of integers or numbers, right? You have a list, and it works for all those things. That's because it's a polymorphic type. And that's what this type signature is explaining. If you've got a lowercase thing, go ahead, Joe.
Has anybody here not dealt with a strictly typed language? Has anybody here not dealt with a strictly typed language before? You haven't.
Okay. So we all kind of know at least something about polymorphism and types. So that's what that is. And then, so here we've got a list of anything that can be in a list, and we return a bool. That's for isEmpty right there. Let's go to one that's a little more complicated, something that takes two arguments, and maybe list isn't the best thing to be using as an example. Oh, look, let's go with signals instead. Yeah.
Oh, yeah,
that's great. Here we go. Let's go with repeat. Repeat a string n times. See this example down here? Repeat 3 ha equals ha ha ha. Okay, so we've got 2 arrows here and 3 things separated by arrows. What does that mean? That means that the first 2 are function arguments. So this function takes 2 arguments and returns a string. So the last arrow always indicates what the function returns. And if there's no arrow at all, then it's dictating that repeat. Like if this were just repeat colon string, it would mean that repeat is a string. So that would be like repeat equals blah, right? It would just be assigning a string to the value of repeat. Okay, yeah.
Or like in the like a length function, or a function that takes in no parameters. I guess that length doesn't apply. But I think the one thing that's interesting about this is I thought it was really stupid how the return type didn't have a special syntax. Like, here's all your parameters, and here's your return type, and they're all just the stupid little arrows. Until I learned about the automatic currying in Elm that's just like in other languages, and then it started making a little bit more sense. So if you don't know what that is, that's okay.
That's exactly what we're about to touch on.
Oh.
Automatic currying. So the reason for these arrows, the reason it's not defined like other languages like Java, where you have a function that takes 3 arguments, is that all of the functions in Elm take up to the number of arguments that are defined in their type signature. So repeat takes up to 2 arguments. If you just give repeat 1 argument, what you get back is what comes after the arrow. And what comes after the arrow? Do I have a brave soul? Exactly right. You get a function that takes 1 argument that's a string and returns a string. Perfect. So you all know what currying is. I probably don't even need to explain it anymore, but there you go. So if you're ever curious about it, you just say, oh, what happens if I only pass in 2 arguments here? And then you just look at whatever comes after the arrow, and that's what you get out, a function that takes a string and returns a string. Or maybe you get out a string itself. Okay, so those are the basics of the Hindley-Milner type notation as far as Elm goes. Let's quickly talk about unit, which I don't see in here, maybe in task. And the only reason I bring this up is because it's confusing. It was confusing to me when I first ran across it. And I don't see anything that is showing it. Sometimes you'll have oh, here it is, look. Sleep. Sleep takes a time value, and it returns a task, And the task has 2 types it carries with it. We'll talk about that in a second. The task has an error type of X. Where did it go? Sleep. I lost it. An error type of X and a return type of unit. Now that unit, those open and close parens, they're a placeholder for nothing. So instead of null, right, because we don't have nulls in the language, what we're doing is we're saying that this is a function that returns a value that, or a task rather, and when that task is fulfilled, it's going to give back nothing useful. So we just put unit there. And when it finishes, it puts out unit, and it's just not useful, except for to know that, like, oh, the task is done, right? So that's what that's for. So if you ever see the open and close parens all alone, it means unit. Unit is a magical fairyland thing that... No, do you know, Taylor?
Yeah, I think it's both. If it's in the type signature, it's obviously a type, but if you type it, you can return it as well. So it's both the type and the value.
There you go. Very good. Right, so let me tell you a horrible thing I did, and you can understand why unit was useful for that. I wrote a thing in Elm where I wanted to get a bunch of unique user IDs or UUIDs to assign to objects that I was creating, and I didn't want to do that asynchronously because it really didn't fit in the flow of the program. So I wrote a native module in Elm that used JavaScript to generate a unique ID and return it, which is impure. So I'm going to get like strung up and burned by some purists out there. But I made an Elm function that wasn't pure that you call, and I would pass in unit, and I would get back a unique ID. Does that make sense? So I had to call the function, and you can't just like, it's not like in JavaScript where you just type a function name and then open and close parens, because the way you invoke a function is by passing an argument to it, right? And I needed an argument, and in this case, the argument was unit, because I didn't care what the argument was, I just wanted a unique ID out of it. Now don't tell anyone I did that, because I don't want to be burned at the stake. Okay, any questions before we go over type aliases versus types? Awesome. Maybe we don't even need to go over type aliases versus types. But we will anyway for the sake of those who are watching on the video. Okay. So, Elm. Type foo. Does anyone know what's happening here? This is a type constructor. So I'm actually creating a new type that the compiler will understand. Now this type is what's, if I'm not mistaken, is called a sum type. It's a concatenation of other types, which we can put right here. So type foo equals, or actually maybe there's a better way to do this. Let's say type cat, and let's say I've got different types of cats. Actually, I'm going to do dog because I'm a dog person. Type dog, and here I'm going to say like collie and Aussie and what's another dog? Yorkie. Thank you. Great. So now what I've got is a new type called dog, and I've got 3 type constructors called collie, Aussie, and Yorkie. These take no arguments, and they return a type of dog. So in other words, these are both type constructors and values of type dog. I hope that makes sense. So I can go ahead and I can say like, I've got a function foo that takes in a dog, and it returns another dog. And so I'm going to say foo dog equals, and here we can actually match on the type of dog that comes in based on the constructor that was given. And so here we can say case dog of, and now let's match on it, collie. So I'm looking at the constructor of the variable of the value dog, and I'm matching on that, which is really useful. So if I have a collie, I'm going to return an Aussie. If I have an Aussie, I'm going to return a Yorkie. And if I have a Yorkie, I'm going to return an collie again. And so actually, I guess what this should be called is like loop dogs, right? So it gives you the next dog, whatever that is. Now let's say this is kind of cool, but it needs to be a little bit more powerful. We need to be able to associate data with these types, right? So maybe a collie has a string that describes its name and a Boolean that describes whether it has a tail or not, right? And maybe Aussie has a string that's like what color it is. Dink. Sorry, right there. Okay, so here, if we do that, then in this case statement, we can actually deconstruct this value to be its constructor type, and then the values that it carries with it. So collie would be constructor type of collie, and I match the first string, which we said was name, second, the bool, which is like tail or not, and then Aussie right here had color. I think that's what it was, yeah. Okay, great. So this is a type constructor matching a type constructor, I think. I could be wrong about that. And this is a value. So this is an example of, no, I'm sorry, these are both values. Let's make this better. Oh, right here. So Aussie, let's say we're going to return Aussie, right? So in this circumstance, since Aussie takes a string argument to create a dog type, what we're actually getting back if we just pass back Aussie here is a function that takes a string and returns a dog. In that way, it's a constructor, right? So in order to actually return a dog from this here, we would have to say Aussie red or something. Pass in some color. Now that is a dog right there. Dink, instead of a constructor. So that's a quick example that I'm afraid I didn't explain very well of how type constructors work and the sum types. Let's go back over that. If you need to afterward, you can come talk to me and I'll try to make it less confusing. Now let's talk about type aliases. Yes, you do. Thank you. Thank you very much. There, that is more correct syntax right there. All right, so type alias. Let's comment all this out, pretend it never happened. Type alias dog equals. Okay, so whenever you see type alias, you're going to know that another type is going to follow after the equal sign, because all we're doing is taking some existing type and giving it a different name that we can refer to it with. We're also, yeah, and this sometimes also creates a type constructor, but we'll talk about that in a second. So often type aliases are used to refer to records. And a record in Elm looks like this, which is kind of like a JavaScript object, but a little different. And so here we can have some attributes, name, string, and color is also a string. So this is what's interesting. This right here, from here to here, is a type in Elm. You could say, for example, like make dog or like get dog or something like that. Then it takes in a dog. But if we don't have the type alias, we could actually type name string color string. And then it returns name string color string. That's actually a type alias right there. Or I'm sorry, that's actually a proper type because we're describing a record with these attributes. But it's extremely painful to do that all the time. So we often set up a type alias that says, all right, instead of writing out this object and all of its attributes everywhere, I'm just going to give it an alias of dog. Whoop. And then Elm knows that wherever you use dog, when you've assigned it as a type alias, you actually mean an object with these attributes. Also, this can be used now as a constructor, kind of like we were talking about above. So you can say, for example, dog fill, and the return type of this is going to be, well, there's not a good way to write that. The return type of this is going to be a function that takes a string, the color, and returns a dog. And it'll just take arguments in the order they were defined right here. So you can say dog, and it's auto-curried, and so if we said dog fill red, it would return a dog. That's basically it. So, oh yeah.
If you had a cat with a name and color, same exact signature, are they interchangeable?
That's a great question. I don't think so.
So it's the signature plus the name, the alias.
I-
They all
Yeah, I think that's right. But I might be totally wrong. I've never tried it. That would be an interesting thing to see.
In TypeScript, it's completely just the signature.
That could be here too. Because another thing you can do here is you can say like, type.
Yeah, don't they do that with strings sometimes? With like type URL is type alias URL is actually string, and then you can actually use a string as well as.
Oh,
That's exactly right.
You can.
Yeah.
switch it.
Okay, great.
So it's like C++.
So careful not to pass in cats when you have dogs. But, but in that case, you actually, if you want more strictness around there, you might use a typed union instead
right.
and call it like type animal, right? And then you've got, oops, I shouldn't have put that there. Then you've got a cat, and maybe the cat takes, is an object with a name. And then maybe you've got a dog, and it also has a name. But then you can know for sure whether you're dealing with a cat or a dog based on its constructor. All right, that's what I've got. Any questions? Okay, let's get hacking. Thanks, everybody.